like I'll just start the video here. Okay, so y-intercept x is 0. So we sub in, we have our equation. And we're going to replace x with 0. Replacing x with 0. 5 times 0? 0. Or 0 plus 15, what's that? 15. Divide by 3, and y is 5. So y-intercept equals 5, or how else can we write that? 0, 5. 0, 5. Okay, so this is what we're going to do. Change this equation that's there. We're going to change it to y equals, I had it right here, 2x minus 4. Okay, can you change this equation to y equals 2x minus 4? And I want you to solve algebraically for the x and y intercept. So the x-intercept, that's when y is equal to 0. 0 equals 2x minus 4. Add 4 to both sides. 4 equals 2x, and then divide by 2. X-intercept equals 2, or as a point, 2 comma 0. Next one, x is equal to 0 at the y-intercept. Y equals 2 times 0 minus 4. What does that equal? Minus 4. So your y-intercept is negative 4. Or as a point, 0 comma negative 4. Beautiful. Not so bad? That's too hard? Okay, let's do another graph question. Well, the nice thing is the numbers are already in there for you. Yay! Okay, how would if our input is our t, our x variable, right? And y is always the output. V is going to be the output. So we're talking about the value of a car. Lisa purchased a car for $20,000, steal of a deal. The value of the car can be represented by the formula. So what's happening here is, like, as the years goes on, what happens to the value of the vehicle? Goes up or down? That's why they say buy the most expensive house you can and the cheapest car you can. Because usually the house market, the prices go up, but vehicles depreciate. They always go down. Worst investment. Unless it's a specialty vehicle that's like going to retain its value, which is not very common. But then you may as well just park it in your garage. Yeah. Oh yeah. Any vehicle. The second you drive it off the lot, it's depreciated thousands of dollars. Worst investment. Yes. So with that being said, let's graph. Okay, plug these in. So I would like you to plug in. So with 0 here, you're going to type in your calculator 20,000 minus 1,250 times 0. What would that equal? No. Yeah. 1,250 times 0 is 0. What's 20,000 minus 0? 20,000. So, your first point. 0 and 20,000. Okay? Next one, type them in. Fill in the chart. Use the equation, fill it in. What'd you get for 4? 15,000. Okay. And 6 then would be 12,500. Okay. So plot these. I'm going to change my view. Better. Okay, 2 is 17,500. 4 15, 6, 12,500. Okay. You plot those points. And it says connect the points with a straight line. Does anyone need a straight edge? You want one? Put your hand up. I'll bring you one. Okay, connect those points. Very hard to extrapolate or interpolate data. We'll talk about what that means. So extend the line. So don't just connect those points. I want you to extend it all the way to the axis, the x-axis. Okay, extend that line. Now, why does it make sense to connect these points? Because they're continuous. Why is it continuous? Does a point make sense halfway between? Yeah, how about even a quarter, or like a quarter between? Yeah, you can have decimal of money, right? And same with time. All right, so grab your straight edge, connect the points, and extend it all the way to the axes. Now, does it make sense to have negative money or negative time? No. So the graph only exists in this first quadrant. We're going to talk about that in the next couple of days, about domain and range. When does it make sense to continue both forever up and down, left and right on the graph, or does it limit it? Yeah. Sometimes negative money does exist. Yes. Yeah, sometimes you can. There is a, yeah, here and there. That's not a nice feeling. Okay, so yeah, but time, definitely not. Also, you could time travel. We're not there yet. I don't think we'll ever get there, because then wouldn't they have come back? You never know. Maybe you're like okay. If you go back in time word, yeah. If you go negative time, exactly. Okay, or it's really, you're paying really big money and you don't even own it. Let's talk about this. What does the ordered pair 0, 20,000 represent? Okay, well, first off, which intercept is it? It's the y-intercept or the v-intercept. Oops, that sounded good. The y-intercept. So think about the variables. What does the x stand for? The age of the car. It says T is the age of the car in years. What's the Y stand for? The value of the car. Yeah. What's your question, Bhakti? This is, why do I know it's the y-intercept? Because x is 0. Right? So, in terms of the context of the question, this is when the age of the car is what? 0. Exactly. Age of the car is 0 years. And what does the 20,000 represent? Its value. And so at 0 years, the value is 20,000. So the age of the car is 0 years, and its value is 20,000 when it's brand new. Now let's be honest. This is not realistic. We're extending this line, but in real life, there comes a point where it's probably going to like curve and plateau. Because a car is worth, well, can you have a car that's 20 years old and still has value? Absolutely. Maybe not much. And even if it's dead, you could probably get something for parts. So really, we're just extending this line. This is all the data we're given. Right? Do you think stuff like this actually exists? Yeah. Who would use that, like this type of data? You know how like car value goes down, but how come up with a lot of So some of them are really expensive. Usually they've been either rebuilt or like still mint condition. Yeah, they are antique. So some cars retain value, most don't. Yeah. Who would find this information useful? Car salesman. Yeah, if you want to sell your, like, have you ever heard about trading in a vehicle? Yeah, right? Then they like to go look something up. Have you ever heard of the Blue Book? Yeah. Some of you, yes? Judge Judy, yeah. Totally, right? Because your car, one day, for insurance purposes or whatever, if you get an accident, how does the insurance company tell you, like, here's the money for your vehicle? There is actually something called the Blue Book, and there is like a formula that works out for particular models, like how many kilometers and how old it is, will tell you its value, right? Because how do we, you might find that worth more. Always, actually, you'll find it to you worth more than the insurance company will, but that's how it works. Okay, so that's a really important part of the lesson here, is understanding that intercept. So use the graph to estimate the t-intercept. So just a side note, that we could have also called B a v-intercept, because it's a value intercept. Okay, so what does it look like the t-intercept will be? About 16 years. And so what would it represent in the context of this question? What's zero? Dollars. So after 16 years, the value would be $0. So this was 16, 0. All right, I'd like you to do the following. Use your graph, estimate the value of the car after 3 years, 10 years, and 14 years, and fill that in right below. It's important because we have to talk about a definition again. Let's do it together then. Okay, 3 years, where does it land? 16,000 or a little bit above 16,000? Yeah, mine looks like 16,250. Does yours? No? No. Yours is exactly 16? Mine's 16,250. Yeah. Yeah. Okay, how about 10 years? That one's nice and pretty. 7,000 and what? 7,500. Chase, did you use a ruler? What? Okay, well then write down what you wrote. We're going to use a formula to verify after. Okay, and 14 years. That one's a little nicer, isn't it? Can we not agree on that one? 2,500? Yeah, that's what I get too. All right. So here's the thing, guys. Here's some definitions. You might have remembered these from grade 9. If we're estimating between two given points, what's that called? Yes, interpolate. Okay, so that's the estimate for 3 was interpolation because that was between two given. If we're predicting, okay, so the last two, the 10 and 14, was predicting outside the graph that was given, the points that are given, what's that called? Extrapolation. Extrapolate, yeah. Extra, we're going extra. We're going the extra mile to predict beyond. Interpolate, it's inside the data, right? Inside, extrapolate, going extra, beyond. Okay. Well, we're gonna verify this 2 here. Okay, so it says use the formula to verify D. So let's plug into the formula 20,000 minus 1,250 times 10. What's 1,250 times 10? You get 7,500. Boom, told ya. Sorry, Chase. Something went off with your graph. Okay. Last thing on, let's just skip to H. The original value of the car is what? 20,000. It depreciated by how much per year? Per year. So be careful. Well, okay, so from 0 to 2 years, in 2 years, how much did it go down? Looking at our chart. It went down 2,500 in 2 years. So how much is that per year? Hey guys, let's be very careful of that. That wasn't per year, that was every 2 years. So 1,000, how much? $1,250 per year, and has no value after 16 years. Okay, so what is the homework? Nothing, yeah? Not yet. Okay, not yet. Okay, terminology. Make sure you understand x and y intercepts, right? X-intercepts point where the line, where a line on a graph crosses the x-axis. Y equals 0 and so forth. Other terms you need to know today: y-intercept, interpolation, and extrapolation. Okay. Your homework is the following: page 416, numbers 1, 2a through d, 3a, b, c, f, and 4 through 6. Okay? Okay. That's your assignment for today.